Hello, today we're going to talk about multiplying and factoring. One, multiplying is undone by factoring. All right, so I'm going to show you an example one, how to multiply a monomial through a polynomial. It's the distributive property. And then I always say we're going to undo the distributive property by factoring. It's a very important key here. Factoring is basically undoing the distributive property. So in here you're trying to get rid of parentheses. Right? When you multiply through, you get rid of the parentheses. In here, you're trying to make parentheses. Okay? And we're just going to do like this, the very start of the factoring. We're not going to actually factor out. We're just going to find the GCF. So we're going to find out what we need to factor out in this video. So I'll show you what I mean by that. Now, your goals, how do I multiply a polynomial and a monomial? That's the multiplying part. And then how do I factor a monomial from a polynomial? This is the, again, factoring part. All right. So, example one. You're going to want to take these notes really quick. So, to multiply a monomial and a trinomial, or any polynomial for that matter, you're going to distribute the monomial through the trinomial. Okay, so the single term through the part with three terms. This will be outside parentheses. This will be inside parentheses. You're going to multiply any coefficients. Okay, so again, it is the distributive property. So, I'm distributing to here, and here, and here. Okay? So let's see what that looks like. Multiply any coefficient. So on the first one, negative 2 times 3 is negative 6. And then multiply variables like bases at exponents. G squared times g cubed is g to the fifth, like bases at exponents. Let's hit the middle guy. Negative 2g squared times 6g, positive 6g. Okay, so that's going to give me a positive and or a negative and a positive make a negative. 2 times 6 is 12, and g squared times g is g to the third. So watch the sign. That's what this third bullet's about. Watch the sign, and then like bases at exponents, and we're good. And then the last one, two negatives make a positive. 2 times 5 is 10. G squared times the g to the 0, if you will, or just nothing there. I can write the g squared. All right. So again, multiply any coefficients. 2 and 3 is 6. 2 and 6 is 12. 2 and 5 is 10. Don't forget the negatives with the changing your sign. So positive became negative. Positive became negative. Negative became positive. All right? That is the first example. All right, so let's walk through what I'd like you to do. Here is quick check 1. You can find this in your book, 9.2. All right, if you can't see this on the board. I'm going to have the Mr. Dodge pause the video, okay, and you guys can work on these three problems. Compare your answer with somebody next to you. So I'll give it a pause, and I'll see you in a second. All right, so if I need to distribute the 4b through all three terms in this trinomial, again, I'm going to multiply coefficients. So 4 and 5 is 20. B times b squared is b cubed. All right, plus, I don't have to worry about changing signs because this is positive. 4b times b is 4b squared. And 4b times 6 is positive 24b. All right, the second one, do have to worry about the signs here. So negative 7 times 3 is, this will be b, I'll put it down here, negative 21. H cubed. It's not a very good H. It's not a very good 3. All right. Negative and a negative make a positive. And 7 times 8 is 56. And H times H is H squared. So just one term at a time. And then again, negative and a negative make a positive. And 7H times 1 is 7H. All right. And the last one, 2x times x squared is 2x cubed. 2x times 6x is 12x squared. And 2x times 5 is positive 10x. So hopefully you got those right. Nice little quick hit here. Let's take a look at example 2. So the factoring. All right. Now, when we factor, here's the problem we want to factor. Okay, I know there are like terms here. We can combine those, but let's just for now, keep them separate. Okay. In fact, no, we're not going to do that. All right, so I have to change this very quickly here. I'm going to make this guy squared. There we go. I can't stop the video. Sorry, this will take 2 seconds. Alright, so I think I got this fixed. So, 2x to the fourth plus 10x squared minus 6x. Alright, so what we're going to do is we're going to list the prime factors of each term. Okay, so 2x to the fourth is a term, and its prime factors are 2, because 2 is already a prime number, times x times x times x times x. Now, when you get good at these, which could be right away, you're not going to have to show all this work. And then plus 10x squared, and those are 10x squared is 5 times 2, and x squared is x times x. All right. And then the last one, 6x is 3 times 2 times x. So I'm going to circle any common factors for all the terms. So all the terms have a 2, and all the terms have an x. Okay? That's all they have in common, nothing else. So I just look at one of these commonalities, 2 and x, and what is 2 times x? It's 2x, and that is the GCF, 2x. This right here, don't forget to multiply any numbers. If I had, let's say, every term also had a 3, then I would have to do 2 times 3 times x, which is 6x. But that is not the case here. They only have a 2 and an x in common, so the GCF is 2x. That's as far as I want to get today, just telling me the GCF. All right. So what I want you to work on today in class is page 501. Actually, I got one more thing for you to do. Sorry. I want you to work on these. These 3 problems, quick check 2. I'm going to go over them in just a second. So hit pause, and then I am going to go over these. All right. So I'm going to do the long way for the first one. Actually, yeah, I'll do the long way for the first one, and I'll show you how I do this in my head after. So, 5v to the fifth is just 5. Whoops. Is just 5 times v times v times v times v times v. 1, 2, 3, 4, 5. Check. And 10 v cubed is 5 times 2. So if you know the GCF of 5 and 10, or 5 and 10 is 5, you don't have to show all this. And v times v times v. Okay? And again, circle the commonalities. So 5 they have in common. All right? And then they have 3 v's in common for each one, right? There we go. So the GCF of this is 5 v cubed. All right. If all the terms have a variable, then the lowest exponent will always be what they have in common. This guy has 3. This guy has 5. So they at least each have 3. Okay. Now, in your head, 3t squared minus 18. The GCF of 3 and 18. Well, 3 goes into 18, so they have a common factor of 3. T squared, this doesn't even have a t, so they don't have any t's in common. That is it for this answer. It's just 3. Okay, and then this slightly larger problem, 4, 2, and 6. The GCF of all 3 of those, well, 2 does happen to go into all 3. All right, and 2 is a prime number already, so that's a GCF. And then b cubed, b squared, and b. They all at least have 1 b, right? This guy has 1 b, so that is the GCF. That is my answer. All right, hope this helps. Your homework again, 501, 1 through 18. Is what I want you to work on today. 501, 1 through 18. Thanks, and I'll see you guys Wednesday. Should be the last time I'm out for a while. See you guys later.